Good day, everyone. Welcome to another episode of CHM 111. And in this particular video, we'll be dealing with haloalkanes. Haloalkanes. Please take note. Haloalkanes, haloalkanes, they are also referred to as halogenoalkane. Halogeno what? Alkane, or you can also call them the alkyl halide. The alkyl halide. So they have the general formula of R double bond directly bonded to S. Why this S simply means we have chlorine, sorry, we have fluorine, we have chlorine, we have bromine and what? And iodine in the periodic table. So halogens or haloalkane, these are alkyl group that is directly attached to halogens. For example, this is an alkane and we believe that this is methane. So when a methane that is an alkane reacts with a halogen, what will happen is that this halogen is going to be in form of like this, as long as you're having a diatomic halogen. All halogens are actually diatomic. So you are going to see except astatine. So as long as you are seeing something like this, this is what it represents. So what will happen is that you are going to have carbon, hydrogen, and here's what is hydrogen directly bonded to nothing. There's another hydrogen here. Okay, let me put it. What will happen is that this hydrogen will be removed from this reaction, and one of the S will be directly bonded to it. Plus one hydrogen, the hydrogen that is removed will be here, and one S that is remaining will be what? Will be here. So this product this thing here, we call it halogen. And the product that is formed is called the alkyl. CH3 is alkyl. Then H here is what? Halide, because it's bonded, it has accepted the electron. Any halogen that have accepted the electron is called halide. So we call this an alkyl halide, halogenoalkane, or haloalkane. Please take note of that. So we can easily say halogens, they are formed from the substitution reaction of an alkane. Halogen, they are formed from the substitution reaction of what? Of alkane. So the product that is formed here can be called an alkyl halide, a halogenoalkane, or what? A haloalkane. So please take note of this reaction. But in a situation whereby you have more than one alkane, before we move on, there's needs for me to introduce this real quick. If you have a carbon atom, hydrogen, please. If you have something like this is a balanced structure. And this structure is reacting with a chlorine. What will be the product's form? Now, there is that thing which you call the Markovnikov rule. So according to, we have Markovnikov rule and we have the anti-Markovnikov rule. So if this bond should split, this is actually an addition reaction. If this bond should split, let me put this hydrogen here so that you understand better. If this bond should split, one of the electrons will come to this place, one of the electrons will come to this place. Let me see if we represent this with S. So we are going to have carbon, hydrogen, and here is hydrogen, singly bonded to carbon, hydrogen, and here is what? Hydrogen. So now we have two electrons already. We have 2s already. As long as here is 2s, one s will come here, while the other s is going to do what? To go there. But assuming here is hydrogen chloride, so where will the hydrogen go to and where will my chlorine go to? So in this situation, you are going to apply the Markovnikov rule in terms of knowing where this hydrogen is going to and where this chlorine negative is doing what is going to be attached to. So please take note of this reaction. So but for alkanes, they undergo majorly what we call substitution reaction with halogens. Substitution reaction. But for an alkyne, they undergo what we call addition reaction. And for an alkyne, which is triple bond, carbon triple bonded, here is hydrogen, here is hydrogen, here is hydrogen, here is hydrogen, plus S2, it will give us carbon double bond because one of the bonds will be broken. So when this bond breaks, it's going to form an alkyne, whereby here is chlorine and here is what? Is chlorine. So when this bond break again in another reaction, then it's going to form what? An alkane. So please take note of this. For alkane, they undergo what we call substitution reaction. I believe you know what is substitution reaction. Something is going in, another thing is leaving. Why for an alkane, they undergo addition reaction. You are adding to the reaction without removing anything from it. An alkyne, they undergo double addition reaction. So if you add to them, they are going to form a double bond. Then when you add more to them, they are going to form what? A triple bond. So please take note of the reaction that alkane, alkyne, and alkene undergo under halogenoalkane. So please take note of this. But at the end of this reaction, remember what you are forming is called what? An alkyl halide, a halogenoalkane, or what? A haloalkane. So in a situation whereby you have, for example, this is a compound, and here is chlorine, here is chlorine, here is hydrogen, 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 and here is hydrogen. Let me replace this with hydrogen. We already know that this is a haloalkane. So what will now be the IUPAC nomenclature of this structure? First of all, what is the position of this chlorine? Is it in position 1 from this side, or is it position 3 from this side? If you start counting, if you make this one your carbon 1, it will be in position 3. But if you make this one as your carbon 1, it's going to be in your what? Position 1. Like what I said earlier, you have to follow the side that is closer to the main functional group, which is 1. So here will be my 1, here will be my 2, and here will be my 3. So it will be 1 chloro, 3 carbon atom is what? Is propane. Assuming here is now another chlorine again, it will be 1, 2 dichloro propane. Assuming here is now another carbon atom, chlorine atom again, it will now be 1, 2, 3 trichloro propane. But there are some situations whereby you are going to have 2 or more functional group. 2 or more halogens in the structure. Let's say bromine is there, chlorine is there, fluorine is there, or even iodine. All of them might be there. So in that situation, you have to follow what we call the ABC rule. So the ABC rule simply means you have to write bromine first. After bromine, you have to go further by writing chlorine, further by writing fluorine, then what? Iodine. So they must be arranged in a what? In alphabetical order. So this structure here, if you see this structure in your exam, they won't draw this long rubbish for you. What they will do is that CH2Cl, then here is what? CHCl, then here is what? CH2Cl. This is what you are going to see. So if they have to draw something like this for you, it will be CH3, CHS, then this one is what? CH2S. If you want to, they want to draw this thing for you, it will now be CHCl, CH what? Cl. So most cases, don't expect a diagram like this or a structure like this in your exam. They will usually be represented in a condensed form, a condensed structure. This is what you are going to see in your exam. Not all these ones are very, very easy to name. But if you give you something like this and you are not expert, you definitely fail it. Unless you have to like elaborate the structure or withdraw the structure before you can pick your answer. So let me give you one more structure. 1, 2, 3, 4, 5. And here is chlorine, here is chlorine, here is bromine, here is bromine, and here is iodine. So you already know that you are going to start counting from this side because most of the functional group are attached to this side than this carbon atom. So here will be my carbon 1, my carbon 2, my carbon 3, my carbon 4, carbon 5. Then which of them are we going to name first? Because bromine is there, chlorine is there, and iodine is what? Is there. If you follow the ABC rule, you are going to name the chlorine, the bromine rather, BR. So what's the position of this bromine? 1. Any other bromine again? Yes. 2. How many bromine is there? 2. 2 is called what? Dibromo. Then you now put another hyphen. How many chlorine is there? 2. What are their position? 2, 3. How many chlorine is present? 2. Dichloro. Then we have iodine. How many iodine do we have there? 1. Position 4. 4 iodo. 1, 2, 3, 4, 5. 5 is what? Is pentane. But most of all these long structure, you will not see them in your exam. But please take note. In a situation like this, it will be 1, 2 dibromo, 2, 3 dichloro, 4 iodo what? Pentane. So it's mostly just for you to look at the structure, then tell us where the position of the first of all, identify the carbon longest chain. Then after that, tell us the position of the functional group they are attached to which of the carbon. Then after that, take note of the ABC rule. Name bromine first, then from bromine to chlorine, from chlorine to fluorine, then from fluorine here to what? To iodine. So this is a standard way of naming the halogens. Please take note. The halogens, they are found in group 7 in the periodic table. Group 7 in the periodic table. And when the halogen accepts electron, they accept one electron, they form what we call what? Halide. the electron they accept is from the alkyl group. So the alkyl group is capable of giving them one electron. So when the alkyl group give them electron, when they accept the electron, they will definitely form, or when they combine with a positively charged atom, then at the end of the whole thing, the product that will form is called what? An alkyl. An alkyl halide, a halogenoalkane, or a haloalkane. So these are the basis for haloalkane. If you have any question regarding what I've explained so far, please feel free to drop that in the comment section. But before you go, as usual, I have an assignment for you. In a structure that have chlorine, that have iodine, that have bromine, and that have fluorine, if you are to name this structure, where are we going to start naming from? So please rearrange this in a standard way. The another thing again is that if you have a structure like this, and here is double bond, chlorine is here, chlorine is here. Now, as long as chlorine is here, if you want to start naming, it doesn't mean you start naming from the side that is close to the chlorine. Halogen are double bond. Double bond has a higher priority compared to halogen. So you have to start naming from the side that is closer to the what? The double bond, which is this side. I repeat, this is a functional group called what? Haloalkane. And this is another functional group called what? Alkene. Alkene are the halogen. Which of them is higher? Is the alkene. So you start naming from the alkene. 1, 2, 3, 4. So the name will be 3,3-dichloro. How many carbon atoms do you have here? Is 4. But the position here is 1. But 1 what? In. That will be the name. 3,3-dichloro, but 1 in. Please, if you have any questions based on whatever I've explained so far, feel free to drop that in the comment section. I'll be waiting for you to answer all your questions. And don't forget, if you have a structure that have this formula, that have these halogens, how will I name this structure and how will I arrange the structure? So please tell us which of them will come first, which of them will be the second one, which of them will be the third, and which of them will be the last element. Thanks for watching. I hope to see you in our next episode. But for now, goodbye.